Hello there and welcome to Scientific Serenity. Everything you hear here is carefully researched and prepared for you. Now, take a deep breath. Let the darkness become gentle. Before we begin, you may notice your body starting to relax. A gentle yawn may arrive. Your breathing may slow. As this story unfolds, your mind will drift naturally towards sleep. By the middle of this journey, rest will come quietly, and when you wake, you may feel calmer, because tonight, you fell asleep through science and learned something most people never will. If you see me as someone from your own family who researches and prepares this knowledge for you, subscribing, liking, and leaving a comment would truly mean a lot to me. And let the story begin. Like all great mysteries, it begins not with an answer, but with a profound, elegant question. Imagine, if you will, a diamond. Not the glittering gem set in a crown or a ring, but diamond in its purest, most geological essence. A crystal of carbon forged under unimaginable pressure, deep within the mantle of the earth, over 1 billion years ago. It is born in darkness, rises through volcanic pipes, and is discovered in mines and rivers. It sparkles because it is pure, because it is clear, because it bends and captures light. This is the diamond we know, the diamond of rules. Now erase that image. In its place, picture this: a stone black as the space between stars. Not shiny, but matte, almost porous looking, like a piece of charcoal or hardened meteoritic iron. It does not sparkle. It does not reflect. It absorbs. Light falls upon it and seems to sink into its surface, swallowed whole. It feels heavy, dense, ancient in a way that has nothing to do with earthly geology. It is found not in the classic diamond mines of South Africa or Siberia, but only in two unrelated riverine deposits on Earth: the riverbeds of Bahia, Brazil, and the alluvial plains of the Central African Republic. It has no known mother lode. No volcanic pipe points to its origin. It is quite simply a geological orphan. This is Carbonado. The name itself is a clue. Given by Brazilian garimpeiros, prospectors, in the 18th century, Carbonado means carbonized or burnt. They thought it looked like a piece of coal that had been through a fire. And in a way they were more right than they could have ever known. For Carbonado is not one crystal, but a chaotic, glorious aggregate of millions of nanometer-sized diamond crystals, fused together into a polycrystalline mass. Under an electron microscope, it looks less like a gem and more like a galactic cluster. A tiny, solid universe of carbon spheres, each one a perfect diamond, welded together in a defiant, unbreakable community. This is the first great anomaly. A typical diamond is a single, continuous crystal lattice. It cleaves along specific planes. Carbonado has no cleavage planes. It is isotropic, equally hard, equally stubborn in every direction. It is, in fact, the toughest form of natural diamond on Earth. It cannot be cut by conventional diamond saws. It can only be worked by another fragment of itself. It is a stone that only obeys its own kind. This is not a story of treasure, but of evidence. A piece of evidence that has been sitting in plain sight for centuries, waiting for us to ask the right questions. The first question is the simplest and the most devastating to our understanding. If you are a diamond, why are you here? For geology has a quiet, unyielding voice, and it whispers that Carbonado could not have formed where all other diamonds formed. The evidence is in its body. It contains traces of elements that are forbidden in the deep mantle, significant hydrogen and nitrogen in a form that speaks of a low-pressure, high-energy environment. It is porous, shot through with microscopic tunnels and cavities, a structure impossible to maintain under the crushing pressure that births classical diamonds. It is a stone that carries the ghost of open space within its very flesh. So, we are left at the edge of the known world, looking at a black stone that should not be. Its very existence is a quiet rebellion. It is a reminder that sometimes, the most profound truths arrive not with a fanfare, but as a patient, heavy, silent weight in the palm of your hand. The black stone, the silent lap, the unanswered question. Feel the weight of that mystery. It is not an anxious weight, but a grounding one. A promise that the world still holds wonders that defy the textbooks. A lullaby for the curious mind, inviting it to rest in the comfort of not knowing before the journey to understand begins. To understand the rebellion of Carbonado, we must first pay homage to the established order. So let us descend in our minds to where traditional diamonds are born. Deep beneath the continents, 150 to 200 kilometers below your feet, lies the Earth's mantle. Here, pressures exceed 50,000 times the atmospheric pressure at the surface. Temperatures soar above 1,200 degrees Celsius. In this hellish, luminous dark, carbon atoms, arranged in the loose, chaotic structure of graphite or other minerals, are subjected to an alchemy of force. The atoms are squeezed, rearranged, and compressed into a new, indomitable configuration. A tetrahedral lattice where each carbon atom is bonded to 4 others in perfect symmetry. This is the diamond lattice, the strongest atomic bond in nature. It is a masterpiece of pressure and time. These diamond crystals form over millions, sometimes billions, of years. They are then carried upward in rare violent eruptions of kimberlite magma, rocket ships of molten rock blasting through the crust at supersonic speeds, delivering their precious cargo to the surface in carrot-shaped pipes. This is the classical, venerable, and well-understood genesis of a diamond. It is a story of the Earth's interior, a deep, slow geological sigh. Now bring Carbonado into this picture. It shatters the frame. First, its polycrystalline nature. A kimberlite diamond is a single, sometimes flawlessly clear crystal. Carbonado is a chaotic multitude. Imagine taking billions of perfect, microscopic diamonds, each one a flawless crystal, and sintering them together in a furious cosmic furnace. There is no gradual, ordered growth here. It is a sudden, violent, conglomerate birth. This texture alone tells geologists that Carbonado did not crystallize slowly from a carbon-rich fluid in the mantle. It was formed in an instant from a cloud or a plasma, where carbon nuclei were forced to aggregate and bond all at once. Then there are the telltale chemical signatures. Classical diamonds often contain tiny inclusions, minute capsules of the mantle environment where they formed. These can be minerals like garnet or olivine. Carbonado's inclusions are different. They contain minerals like osbornite, titanium nitride, and silicon carbide, materials commonly associated not with Earth's mantle, but with meteorites and the circumstellar environments of certain stars. More strikingly, Carbonado is rich in light isotopes of carbon. On Earth, biological processes, like photosynthesis, prefer the lighter carbon-12 isotope over the heavier carbon-13. The carbon in living things is thus lighter. Classical mantle diamonds have a carbon isotope ratio that is distinct from this biological signature. Carbonado mysteriously often carries a light isotopic signature, one that whispers of a process involving life, or something that mimics life's preference. But the most haunting clue is the hydrogen. Diamonds from the mantle are notoriously dry. The extreme conditions squeeze out volatile elements like hydrogen. Yet Carbonado is hydrated. It holds within its porous matrix traces of water and hydrogen-rich compounds. To a geologist, this is as shocking as finding a perfectly preserved rose embedded in volcanic lava. It is a signpost pointing not down but out. Out, beyond the atmosphere, beyond the pull of our world. The silence of the geological record is deafening. There are no known geological processes on Earth that can create a massive, polycrystalline diamond aggregate with these chemical traits. The Earth tries to speak but has no words for this stone. So, science does what it must do when faced with an impossibility. It looks beyond the Earth. And so, the mystery deepens but its nature changes. The question shifts from, how did you form? To, where did you come from? We have eliminated the Earth. We are left with the cosmos. We have followed the clues to the edge of the world and now stand looking up. The evidence has led us here to a conclusion that feels less like science and more like poetry. But the best science often does. Carbonado, the black diamond, is not a child of Earth's deep, patient geology. It is a foundling from the stars. The hypothesis that emerged in the late 20th century and has gained considerable weight since is as breathtaking as the stone itself. Carbonado is the remnant of a supernova. Let us travel back over 3 billion years, perhaps more. In our arm of the Milky Way, a star much more massive than our Sun reaches the end of its life. It has burned through its nuclear fuel, its core collapsing under its own gravity in a final, defiant act. The rebound from this collapse triggers a supernova explosion, one of the most energetic events in the universe. For a brief moment, it outshines its entire galaxy. In that hellish forge of unimaginable pressure, heat, and neutron flux, elements are transmuted. Carbon nuclei are bombarded, squeezed, and fused in the chaotic aftermath. In the expanding shock wave of this stellar death, clouds of carbon-rich material are ejected into space. Within these clouds, conditions are just right. Extreme pressure from the shockwave itself, but not the sustained directional pressure of a planetary mantle. Here, carbon atoms, seeded with isotopes forged in the stellar furnace and bathed in hydrogen, begin to nucleate. They do not have time to grow into large single crystals. Instead, they form countless nanodiamonds which collide, fuse, and sinter together in the microgravity of space, creating a porous, polycrystalline mass, a carbonado. It is not carved or grown. It is accreted like a cosmic snowball of diamond dust. This origin story explains everything. The polycrystalline texture, the light carbon isotopes forged in specific stellar nuclear processes, the presence of hydrogen and nitrogen, abundant in stellar atmospheres and supernova remnants, and the exotic mineral inclusions like titanium nitride. It even explains its arrival on Earth. These diamond-bearing chunks of stellar debris, ranging in size from pebbles to boulders, became incorporated into asteroids or comets. One or more of these bodies, in the early violent days of our solar system, streaked through the atmosphere and impacted the young Earth, scattering their strange cargo. The locations in Brazil and Central Africa? They may be the eroded remnants of a single vast strewn field from an ancient impact, later separated by the slow dance of continental drift. Think of it. The stone in the laboratory, under the gentle light, is a piece of a star that died before our planet was even fully formed. It is not merely old, it is preterrestrial. It witnessed the dawn of our solar system. It is a tangible piece of cosmic history, more ancient than any rock native to Earth. This realization brings a profound shift in perspective. The mystery is not solved, but transformed. The weight of the stone is no longer just physical. It is the weight of time and distance. It is the weight of a journey across light years and eons, ending quietly on a velvet pad in a silent room. And then we return. The chord fades into the soft plink of a water drop, the gentle scratch of the pencil, the quiet breath. The black stone sits unchanged, holding its secret now a little less tightly. We have been introduced to the mystery. We have felt its edges. We have heard the first chapter of its epic interstellar biography. Now it's time for our second part. In our first chapter, we met the enigma, a diamond that breaks all rules. Now we descend from the realm of wonder into the meticulous, dusty world of forensic geology. This is the story not of where Carbonado came from, but of where it decidedly did not come from. This is the process of elimination written in stone, a silent argument between a rock and the entire history of our planet. Our scene opens not in a starry sky, but in the alluvial plains of the Abete River in Bahia, Brazil, and the similarly unassuming river gravels of the Central African Republic. For centuries, these were the only known sources of Carbonado. Prospectors, sifting through sediments for gold and conventional diamonds, would occasionally find these black, lumpy stones. They were curiosities often set aside. Too hard to cut, too dull to sparkle, they held no value in the gem market. Their value was hidden, waiting in their atomic structure. The first scientific whispers of Carbonado's strangeness began in the 19th century. Geologists, trained in the dogma of diamond formation, were perplexed. Diamonds were supposed to come from kimberlite pipes. ancient volcanic vents that were geological needles in a planetary haystack. Yet, no kimberlite pipe has ever been found associated with Carbonado. Not a single one. The stones appeared as isolated, alluvial orphans, worn smooth by rivers but with no parent rock to point to their origin. In geology, this is the equivalent of finding a newborn child in a meadow with no footprints leading in or out. The investigation begins with the stone's body. Under the petrographic microscope, the polycrystalline chaos of Carbonado tells its first damning story. A kimberlite diamond forms from a carbon-rich fluid or melt, growing slowly atom by atom into a single coherent crystal lattice. Its growth zones can be read like tree rings. Carbonado shows no such peaceful history. Its structure is one of violent aggregation. The nanocrystals are jumbled, interlocked, and cemented together in a way that suggests they were formed simultaneously and then slammed into one another. This texture has a name. It is a clastic texture, more akin to sandstone, a rock made of cemented sand grains, than to a crystal grown from a melt. The first law of diamond genesis is broken. Carbonado did not crystallize. Next, the detectives turn to chemistry. Using instruments like the mass spectrometer, they perform an isotopic autopsy. Carbon on Earth comes in two stable isotopes, carbon-12 light and carbon-13 heavy. The ratio of these isotopes is a fingerprint. The mantle, where classic diamonds form, has a fairly consistent, heavy fingerprint. Organic matter on Earth's surface, the remains of life, has a very light fingerprint, because photosynthesis prefers C12. When scientists measured Carbonado, they found its carbon isotope ratio was staggeringly light. It fell squarely within the range of organic carbon. This result sent shockwaves. Could it be biological? Was Carbonado formed from the compressed remains of ancient forests? For a moment, a terrestrial, even biogenic, origin seemed possible. But the other evidence screamed in contradiction. No biological process can create nanocrystalline diamond. No earthly pressure could create this structure from coal. And crucially, the hydrogen and nitrogen signatures didn't match any known biogenic pathway. The light carbon was a red herring, or rather a cosmic clue. It pointed to a nuclear, not a biological, process. The kind of isotope fractionation that happens in the frenzied nucleosynthesis of a supernova. Then there is the evidence of the pores. Carbonado is famously porous. Up to 10% of its volume can be tiny, interconnected voids. To a geologist studying mantle diamonds, this is heresy. The pressures at 150 kilometers depth are so immense that any pore space would be instantly crushed. A porous diamond from the mantle is a physical impossibility. It would be like finding a perfect, airy sponge forged in the heart of a hydraulic press. These pores are ancient vacancies, sealed into the stone at its birth, in an environment where pressure was intense but perhaps transient, and where gases like hydrogen could become trapped. The evidence mounts, layer upon layer, like sediment itself. We now turn to the most celestial of clues, the exotic inclusions trapped within Carbonado's stony heart. Inclusions and minerals are time capsules. In a typical diamond, you might find a tiny speck of garnet or olivine, minerals common in Earth's upper mantle. They are familiar, telling a story of depth and heat. Carbonado's inclusions tell a different story entirely. Embedded within its nanocrystalline matrix, scientists have identified minerals that are extraterrestrial in their implication. Osbornite, titanium nitride, is one. On Earth, this mineral is vanishingly rare, formed under highly specific reducing conditions. In space, however, it is a known constituent of certain types of meteorites, specifically enstatite chondrites, and it is predicted to condense in the cooling clouds of material around evolved stars. Finding it in Carbonado is like finding a seashell on a mountain peak. It points to a radically different environment of formation. Even more telling is the presence of silicon carbide, SiC, and specific varieties of it known as moissanite. Silicon carbide is another mineral that forms in environments rich in silicon and carbon but low in oxygen. While it can be synthesized industrially and is found in some mantle rocks in trace amounts, its natural occurrence on Earth is incredibly rare. In astrophysics, however, silicon carbide grains are famous. They are pre-solar grains, dust particles that formed around other stars before our sun was born, and which were later incorporated into meteorites. They carry isotopic signatures that are wildly anomalous compared to solar system averages, fingerprints of their stellar nurseries. The silicon carbide in Carbonado, while not always analyzable as pre-solar due to its small size, is a glaring signpost. It shouts of a formation environment where cosmic, not terrestrial chemistry was at play. Then consider the trace elements, significant concentrations of nitrogen, hydrogen, and in some samples, noble gases like xenon with isotopic ratios that deviate from Earth's atmosphere. Mantle diamonds are famously poor in these volatiles. The conditions of their formation purge them. Carbonado, by contrast, seems to have bathed in them. The hydrogen in particular is a linchpin. Its abundance suggests the stone formed in a hydrogen-rich environment. The only places in our solar system with such abundant free hydrogen are the gas giant planets and the cold, molecular clouds of the interstellar medium, not the Earth's mantle. Faced with this evidence, the theory of a terrestrial impact origin gained some traction. Perhaps the thinking went, a massive asteroid rich in carbon slammed into Earth. The immense, transient pressure and heat of the impact could have converted the asteroid's carbon into diamond right here, creating Carbonado in a flash. This is a plausible mechanism. We know it can create microscopic diamonds. But the impact hypothesis too falls silent before the facts. An impact would create a localized field of debris, a crater, and a distinct geological layer. No such crater or layer correlates with the Carbonado finds. The stones are found in river gravels over vast areas, suggesting they were dispersed by erosion over eons, not concentrated at an impact site. Furthermore, the complex, porous, polycrystalline texture of Carbonado doesn't match the often glassy or shocked textures of impact diamonds. And most damningly, an impact on Earth would still use Earth's carbon, inheriting Earth's isotopic signature. It would not explain the supernova-like light carbon isotopes or the pre-solar mineral inclusions. An impact might be the delivery mechanism, but it is not the forge. One by one, the doors of earthly explanation close. The deep mantle? The chemistry and texture say no. A shallower crustal process? The pressure and temperature requirements for diamonds say no. A biological origin? The nanocrystalline diamond structure says no. An impact genesis? The isotopic and inclusion evidence says no. The silence of geology is now profound. It is the sound of a mystery that has outgrown its cradle. The earth has been asked in every language science can speak, "Did you make this?" And the earth's answer, read in the stone's very atoms, is a gentle, firm, "I could not." With the earth's testimony concluded, we are left in a quiet courtroom of the mind. The verdict is clear yet staggering. Carbonado is alien. Not in the sense of little green men, but in the purest, most profound geological sense. Its formation occurred outside the domain of earthly processes. It is an exogen, a thing born elsewhere. This realization does not diminish the stone, it sanctifies it. Every scraped surface, every porous void, every nanoscale crystal becomes a sacred text in a language we are only beginning to decipher. The silence of geology is not an emptiness. It is a pregnant pause, making space for a much grander narrative to be heard. Consider the journey implied. This black, unassuming stone in a museum drawer is the end product of a voyage of cosmic proportions. Forged in death, its constituents were created in the cataclysm of a supernova, a star's final generous act of seeding the universe with heavy elements. Condensed in chaos, in the expanding, cooling shockwave of that explosion, carbon atoms and other elements swirled, collided, and under intense but fleeting pressures, crystallized into nanodiamonds that then accreted into the larger, porous masses we find. Incorporated into a messenger, this carbonado material became part of an asteroid or planetesimal, a celestial traveler in the early violent solar system. Delivered by violence, that traveler struck the primordial earth, shattering and scattering its precious diamondiferous cargo across the young crust. Patiently waited, for billions of years, through the rise of mountains and the drift of continents, through the entire parade of life from single cells to consciousness, these black stones sat, weathering out of rock, tumbling in rivers, waiting. Discovered, but not understood. Finally, a human hand picks one up, sees it as not ordinary, and the long, slow process of listening to its story begins. This is the biography of a stone. It makes the story of any earth-born diamond seem parochial, domestic. Your typical gem diamond has never left the planet. Its story is one of depth and ascent. Carbonado's story is one of interstellar birth, nomadic travel, and traumatic arrival. It has seen more of the cosmos than any human ever will. This chapter, the silence of geology, therefore serves as the crucial pivot. It is the moment we stop trying to fit a square peg into a round hole. We stop asking Earth to explain what it did not create. We respectfully acknowledge its silence and we turn our gaze upward. The detective work shifts from forensic geology to astrophysical archaeology. The questions change from how could this form here to what specific stellar processes could create this exact amalgam of textures and isotopes? In this quiet acceptance, there is a deep intellectual peace. The frustration of the mystery dissolves, replaced by the awe of a confirmed wonder. We are not facing a problem. We are in communion with a relic. The laboratory, once a place of puzzled analysis, becomes a shrine to cosmic memory. As we close this chapter, we have said goodbye to Earth as the sculptor. We have listened to its silent testimony. Now we are adrift in the space between explanations, ready to be drawn by gravity towards the true source of the story, the heart of a dying star. Next up is Episode 3. Birthplace of Impossible Stones. Having left the silent court of earthly geology, we now travel back in time and outward in space to the only arena vast enough, violent enough, and creative enough to account for Carbonado, the death throes of a giant star. This is not a story of destruction, but of transmutation, the alchemy of the universe where base elements become diamond, and where death begets a strange, black inheritance. Our story begins not with a bang, but with a simmering cauldron. Imagine a star not like our sun, but a behemoth, perhaps 20, 30, or even 50 times more massive. For millions of years, it has burned with ferocious brilliance, fusing hydrogen into helium in its core. As each fuel is exhausted, the core contracts, heats up, and ignites the next element. Helium into carbon, carbon into oxygen, neon, silicon, layer upon layer like a cosmic onion. At its heart, an iron core begins to grow. Iron is nuclear ash. Fusion of iron consumes energy instead of releasing it. It is the end of the line. For a time, the star is held up by the sheer pressure of radiation from the ongoing fusion in its outer shells. But the iron core grows inert and heavy. When it reaches a critical mass, about 1.4 times the mass of our entire sun, a catastrophic failure occurs. In less than a second, the core collapses under its own gravity from the size of Earth to the size of a city. The protons and electrons are crushed together, forming neutrons and neutrinos in a process of unimaginable density. The collapse halts only when neutron degeneracy pressure, a quantum force, kicks in, but the inertia of the infalling outer layers is unstoppable. They slam into this suddenly rigid core and rebound. This rebound is the supernova. The energy released in that moment is incomprehensible. For a few weeks, it can outshine an entire galaxy of billions of stars. The shockwave races outward at tens of millions of kilometers per hour, tearing the star apart. But within that maelstrom of pure energy, in the seconds and minutes following the core collapse, is where our Carbonado is born. This is the cosmic forge. Here in the expanding fireball, conditions are unlike any in a planet's interior. Temperatures soar past billions of degrees. Pressures are astronomical but highly transient. Neutrons flood the environment. a phenomenon called the neutron burst. This neutron fluence is critical. It bathes the existing elements, carbon, silicon, titanium, nitrogen, in a storm of nuclear projectiles, transmuting isotopes and creating new ones. This is where Carbonado gets its distinctive light carbon isotope signature. Specific nuclear reactions in the supernova environment, particularly those involving helium burning and subsequent neutron capture processes, can preferentially produce carbon-12 over carbon-13. The carbon ejected from this stellar autopsy carries this light isotopic fingerprint, a direct signature of its violent, stellar birth. It mimics the signature of life not because it is biological, but because both processes, stellar nucleosynthesis and photosynthesis, favor the lighter isotope. It is a cosmic coincidence that serves as a brilliant clue. And what of the hydrogen and nitrogen? A massive star's outer envelopes are vast reservoirs of these light elements. The shockwave blasts through them, but in the turbulent mixing at the boundary between the inner ejecta and the outer hydrogen shell, pockets of material rich in carbon, hydrogen, and nitrogen can coexist under extreme pressure and temperature. A recipe for the formation of carbon-rich compounds and, under the right conditions, diamond. The fireball expands, cooling rapidly. From a plasma of dissociated atoms, matter begins to condense. This is the moment of Carbonado's true birth. Not in the instant of the explosion, but in its cooling aftermath. Here, in the expanding turbulent cloud of stellar debris, we find the unique conditions that solve the remaining riddles of its physical form. Picture a region rich in carbon nuclei, silicon, titanium, and nitrogen, all bathed in residual hydrogen. The pressure, though dropping, is still immense from the shockwave's passage, far greater than anything in Earth's crust, but transient and isotropic, equal in all directions, not the sustained directional pressure of a planetary mantle. Temperature plummets from billions to thousands of degrees. In this environment, carbon does not have the luxury of time to arrange itself into a single, perfect crystal lattice, atom by patient atom. Instead, it undergoes what scientists call homogeneous nucleation. Millions of microscopic diamond crystals, nanodiamonds, form simultaneously, like a sudden frost crystallizing in a supercooled cloud. Each is a perfect tiny diamond. But they are not alone. They are mixed with condensing grains of other refractory materials: titanium nitride, osbornite, silicon carbide, moissanite. There is no quiet settling. The cloud is chaotic. These newly formed nanocrystals collide. They sinter, they fuse together under the residual heat and pressure. Think of it as a cosmic concrete, where the aggregate is nanodiamonds and the cement is more diamond, forged in the collisions themselves. This process creates the polycrystalline porous mass that defines Carbonado. The pores are the empty spaces between those initial nanograins, sealed in as the material compacted. The exotic inclusions are not accidents. They are siblings, formed in the same stellar nursery and captured during accretion. The hydrogen and nitrogen are trapped within the porous matrix, ghosts of the stellar atmosphere from which they all condensed. This formation mechanism explains why Carbonado is not found in small gem-sized crystals, but in massive, often lumpy aggregates, sometimes weighing hundreds of carats. It wasn't grown, it was assembled like a celestial snowball in the microgravity of space. Its toughness, its lack of cleavage planes, stems from this chaotic, interlocked architecture. A blow doesn't find a single crystal plane to split. It meets a monolithic crowd of crystals, all holding fast to their neighbors. Now, this newly formed Carbonado material, along with other dust and debris from the supernova, becomes part of the interstellar medium. It is a speck of stellar ash drifting through the galactic arm. For millions of years, it travels. It may be swept up by shock waves from other stars, or gently nudged by the pressure of starlight. Eventually, gravity begins to draw it and countless other particles together. A molecular cloud collapses, a new stellar system forms, our own solar system roughly 4.6 billion years ago. The Carbonado material is incorporated into the swirling protoplanetary disk. It becomes part of the raw building material of planetesimals, the early rocky bodies that would collide and accrete to form planets. Some of this material, rich in refractory diamonds and exotic minerals, likely went into the construction of certain types of asteroids or comets. These bodies were the delivery vehicles. The young Earth, in its first billion years, was a shooting gallery. The late heavy bombardment period saw asteroids and comets pummeling the planetary surface. One such impactor, perhaps a carbonaceous asteroid or a comet nucleus rich in supernova-derived carbon, struck the primordial Earth. The impact itself was apocalyptic on a local scale, but it did not create the Carbonado. It delivered it. The stones were shattered and scattered from the impact site, buried in ejecta. Over eons, geological processes, erosion, continental drift, worked to disperse them further and bring them to the surface in the only two places we've found them: the ancient cratonic regions of Brazil and Central Africa, lands that were once connected in the supercontinent Pangaea. We have followed the carbon from the heart of a dying star, through the interstellar void, into the chaos of a young solar system, and onto the surface of a newborn planet. The journey is almost beyond comprehension, spanning billions of years and billions of kilometers. Yet, it all converges into the tangible reality of a black, porous stone in a human hand. This convergence is the true miracle, not the stellar physics but the connection it forges. Hold that thought. The Carbonado you envision is not just an object. It is an event horizon between scales. Within its matte, light-absorbing surface resides the nuclear scale, the forces that fused atoms in a stellar core; the atomic scale, the precise tetrahedral bonds of carbon; the nanoscale, the chaotic community of nanocrystals; the human scale, the stone we can hold, weigh, and marvel at; the planetary scale, the Earth that received it; the stellar scale, the star that died to create it; the cosmic scale, the universe that provided the stage. All these scales coexist, peacefully in one silent artifact. This is the profound wow moment. It is the instant where astrophysics ceases to be abstract equations and becomes a sensory, almost spiritual, experience. You are not just learning about a supernova, you are holding a piece of one. The distance between the human mind and the life cycle of stars collapses. This realization carries a gentle, humbling weight. Our sun is a star. It too will die one day. In its death, it will not create a supernova, it is not massive enough. But it will expel its outer layers, enriching space with carbon, oxygen, and other elements. That material will one day become part of new stars, new planets, perhaps new life. We ourselves are made of stardust, carbon, nitrogen, oxygen forged in ancient stellar furnaces. Carbonado is our kin, a more direct and dramatic relative. It is a concentrated nugget of our own cosmic ancestry, unprocessed, unbiological, pure. So, when a geologist peers through a microscope at Carbonado structure, they are not just analyzing a rock. They are performing an archaeological dig on a supernova. They are reading a first-hand account of stellar nucleosynthesis. The light carbon isotopes are the author's signature. The hydrogen is the paper was written on. The osbornite and silicon carbide inclusions are the ink. This stone is a document from a time before Earth, delivered by celestial post and only now being translated. As we conclude this chapter on the cosmic forge, we transition from the spectacle of creation to the inherent nature of the creation itself. We have answered where and how. Now we must ask what. What is it like to be this substance? What are the properties that emerge from such an origin? The next chapter delves into the stone's essence, its legendary hardness, its strange porosity, its metallic luster, and its profound, unyielding loneliness, the qualities that make it not just a scientific curiosity, but a philosophical touchstone. For now, let the magnitude of the journey settle within you. The universe is not a separate, distant place. It is here, in the grounding weight of a stone, in the air you breathe, in the calcium of your bones. Carbonado is a blunt, beautiful reminder of that unity. Now it's time for our fourth episode. Inner world of Carbonado. Having traced its epic journey from supernova to riverbed, we now turn inward to the stone itself. What is it like to be Carbonado? This chapter is not about origins but about essence. It is a meditation on the physical and metaphysical properties that emerge from its violent, cosmic birth. Here we encounter a substance that embodies paradox, both immensely hard and delicately porous, universally tough yet profoundly alone. Let us begin with the most famous of its traits, its hardness. On the Mohs scale of mineral hardness, diamond sits at the pinnacle, a perfect 10. Carbonado is also diamond, so it too is a 10. But hardness can be a subtle concept. The Mohs scale measures scratch resistance. Can mineral A scratch mineral B? A diamond can scratch anything. Nothing can scratch a diamond. But Carbonado adds another dimension, toughness. If hardness is resistance to scratching, toughness is resistance to breaking, to fracture. A standard diamond crystal is hard but can be cleaved along its crystal planes. It has a grain like wood. Carbonado has no such grain. Its polycrystalline, chaotic structure means there are no easy planes of weakness. A force applied to it is distributed across millions of nanocrystals, each bonded fiercely to its neighbors. To fracture Carbonado, you must shatter each of these microscopic bonds individually. It is the difference between splitting a log with an axe and trying to pulverize a brick made of fused sand grains. The former has a path of least resistance. The latter must be defeated utterly. This is why traditional diamond cutting tools, designed to cleave along a crystal's natural planes, are useless against it. The only substance that can effectively cut, shape, or polish Carbonado is another piece of Carbonado, or synthetic polycrystalline diamond (PCD), designed to mimic its structure. It is a material that obeys only its own kind, a closed circle of absolute resilience. In the industrial world, this makes it priceless for the tips of deep earth drill bits and heavy-duty cutting tools, where its ability to withstand insane abrasion and impact is legendary. It does not wear down, it merely sheds a few nanodiamonds at a time, revealing a fresh, equally hard surface beneath. Now run your mind's finger over its surface. It is not smooth like polished gem diamond. It is matte, often appearing almost rough or granular. Under magnification, this is explained by its porosity. Up to 10% of its volume can be microscopic voids, tunnels, and cavities woven through the diamond matrix. This is not a flaw, it is architectural. These pores are the fossilized spaces between the original nanodiamonds that accreted in the supernova debris cloud. They were never squeezed shut because the pressure, though great, was transient. They give Carbonado a lower density than pure diamond and a unique ability to trap gases and fluids within it. Hence the preserved hydrogen and nitrogen that betrayed its extraterrestrial origin. This porosity creates its unique visual signature. A classic diamond is a prism, bending and scattering white light into a rainbow of spectral colors, fire, and reflecting light back brilliantly, brilliance. Carbonado is a sponge for light. Photons enter its surface and are scattered, absorbed, and trapped within its labyrinthine nanostructure. Very little escapes. It does not sparkle, it consumes. It possesses a subdued, metallic, graphite-like luster, a somber, dignified glow rather than a celebratory flash. Its color is not a pigment, but a consequence of this complete light capture and the presence of graphitic inclusions within the pores. It is the black of deep space, of emptiness that is somehow full. This unique combination of extreme toughness and inherent porosity makes Carbonado a material without parallel. It exists in a category of its own. To appreciate its solitude, we must compare it to its relatives. The classic diamond, kimberlite diamond. A sovereign, a monarch. It is clarity and order. Born in the deep, steady womb of earth, it grows as a single, perfect crystal. It is defined by its purity, its planes of symmetry, its ability to play with light. It is prized for its perfection, its rarity, and its symbolism of clarity and eternity. It is the diamond of crowns and promises. The impact diamond, formed by meteorite strikes. A soldier, a survivor. Created in the instantaneous, violent shock of a celestial impact on Earth. Often microscopic, sometimes found in polycrystalline masses called framesite. It bears the scars of its birth, high-pressure mineral phases, evidence of shocking forces. It is a diamond of trauma and sudden, terrestrial transformation. Carbonado. The wanderer, the orphan. It shares the atomic bond of the first and the polycrystalline texture of the second, but its genesis is utterly alien. It did not form in a planet's heart or from a planet's trauma. It formed in the funeral pyre of a star and arrived as a traveler. It is not clear but opaque, not brilliant but absorptive, not a symbol of purity, but a testament to chaotic, creative aggregation. It is not of this world, yet it is here. It is, in essence, alone. This loneliness is not a sadness, but a state of being. There is no other natural material on Earth that shares its complete biography. This solitude translates into its very function. While other diamonds are sought for adornment, Carbonado for most of history was ignored. Too hard to cut, too dull to sparkle. It had no place in the human economy of beauty. Its value was hidden, waiting for the industrial age to demand a substance that could cut through anything and last forever. Its purpose is not to be seen but to work, not to adorn but to endure. Consider its resilience philosophically. Carbonado has survived the cataclysm of a supernova, the loneliness of interstellar space for millions of years, the violence of planetary accretion and impact, the immensity of geological time, burial, uplift, erosion, the neglect of humans who saw a worthless black rock. Through all of this, its fundamental nature, the diamond bonds, remained unbroken. It is the ultimate embodiment of resilience. Not the resilience of staying unchanged. It accreted, it was transported, it weathered, but the resilience of maintaining core integrity through eons of chaos. It is a lesson in endurance written in carbon. There is also a profound silence to its existence. A gem diamond speaks. It catches the light and throws a conversation of sparkles across a room. Carbonado listens. It absorbs energy, light, sound, impact, and dissipates it within its complex interior. It is a stone of profound internalization. Holding it, one does not feel a desire to display it, but to contemplate it. It invites introspection, not admiration. In its essence, Carbonado becomes more than a mineral specimen. It transforms into a philosophical object, a mirror reflecting fundamental truths about existence. Its very properties, forged in extremity, defined by paradox, offer a silent meditation on the nature of strength, identity, and time. Strength in community, not purity. The unparalleled toughness of Carbonado does not arise from a flawless, monolithic crystal. It arises from a chaotic, communal aggregate of countless tiny, perfect crystals. Each nanodiamond is brittle on its own, susceptible to cleaving. but bound together in their multitudes with no single plane of weakness, they achieve an unbreakable solidarity. The strength is in the bond between them in the collective. It is a metaphor for resilience found not in individual perfection, but in interconnectedness, in diversity fused into unity. Identity through history, not appearance. A classic diamond's value is in its present appearance, its clarity, cut, color, carat. Carbonado's value is almost entirely in its past. Its worth lies in its story, etched in isotopes and trapped gases. Its dull, black, unassuming exterior is a disguise for the most epic biography of any object on Earth. It teaches us that true substance often lies beneath the surface, in the layers of experience and history that shape us, not in the superficial gloss we present to the world. Endurance through adaptation, not stasis. Carbonado did not survive by remaining untouched. It was born in violence, traveled through the void, survived a planetary impact, and was tumbled by rivers. It adapted its form, accreting, fracturing, weathering, but never lost its fundamental diamond nature. Its endurance is not the endurance of a statue, unchanged by wind and rain, but the endurance of a mountain, shaped by them yet remaining fundamentally, unshakably itself. Finally, we confront its most poignant quality, its cosmic loneliness. It is the only one of its kind. This very uniqueness is what connects it to everything. Within its crystalline matrix, it holds the history of a star that died before our sun was born. That star's material also became part of the nebula that formed our solar system, part of the Earth, part of us. In its solitude, Carbonado is a singular point of concentrated connection to the universal cycle of death and rebirth. It is alone because it is a direct, unmixed messenger from a specific event in the cosmic past. In being so singular, it speaks for the whole. As we prepare to leave this deep contemplation of the stone's nature and move towards our final, integrative chapter, we carry with us a new understanding. Carbonado is not just an interesting rock. It is a teacher. It teaches that true toughness comes from community. Profound value lies in hidden history. Endurance means maintaining core integrity through change. In deepest solitude, we find our connection to the all. It is a Stoic philosopher rendered in carbon, waiting patiently on a riverbank or in a lab drawer, offering its lessons to anyone willing to listen past the silence. Now it's time for our final episode. We have journeyed through mystery, across the silent testimony of geology, into the heart of a dying star, and deep into the paradoxical essence of the stone itself. Now we arrive at the destination of all great journeys, not an answer but a homecoming. This chapter is an integration, a release, and a meditation on the peace that comes from understanding our place within a story vaster than time. Let us hold the full story of Carbonado in our mind, not as a sequence of facts, but as a single luminous tapestry. A star lives, burns, and dies in a glorious catastrophe. In the aftermath, carbon condenses into nanodiamonds amidst hydrogen and stardust. These accrete into a porous, black mass, a celestial traveler. It voyages through the interstellar dark for eons. It is delivered to a young, violent Earth in a fiery impact. It waits through the rise of continents and the dance of life. It is found, held in a human hand, and its story is slowly, painstakingly heard. This is the biography of a stone, but it is also a reflection of our own. We too are made of material forged in stars. The iron in our blood, the calcium in our bones, the carbon that forms the backbone of every molecule in our bodies, all were cooked in stellar furnaces and scattered by supernovae. We are not just observers of the cosmos. We are its temporary, conscious embodiment. Carbonado is a concentrated, literal piece of that truth. In its silent, black form, it mirrors our own origin back to us, stripped of biology, reduced to the primal mineral fact of our shared ancestry. This realization carries a profound emotional resonance. The awe it inspires is not the awe of something distant and foreign, but the awe of intimacy with the universe. The vastness of space and time is not a void that separates us, but a womb that birthed us. The death of a star billions of years ago is not a remote tragedy. It is a necessary chapter in the story that led to this moment, to your breath, to your awareness listening in the dark. Carbonado thus becomes a bridge between the microscopic and the cosmic. Its nanocrystals speak of quantum bonds. Its origin speaks of galactic events. The mineral and the living. Its carbon is our carbon. Its history is our prehistory. Time past and time present. It is a 3.8 billion-year-old message received now. Human curiosity and cosmic creativity, our science decodes the universe's own art. Holding this stone in your mind's eye is to hold this bridge. Feel its weight, the weight of history, the weight of connection. It is a grounding weight. In a world of fleeting digital moments and surface anxieties, it anchors us to a timeline measured in gig-years, to processes of creation and endurance that humble our daily concerns into proper scale. In this state of integrated understanding, we can finally release the stone, not from our minds but from the burden of being a mere puzzle. We let it simply be what it is, a quiet, profound fact of existence. This release is the key to the deep, cosmic sleep this story promises. For sleep at its best is a surrender of the day's tensions, of the mind's endless queries, of the ego's insistence on separation. Carbonado's story guides us into a surrender of a grander kind, a surrender into our own cosmic nature. When we contemplate its journey, our own small stories, our worries, our triumphs, our fleeting lives, are not erased but placed within a context so vast it transforms them. They become part of the pattern, not the entirety of it. This is incredibly liberating. The stone's resilience teaches us about rest. It endured not by rigid resistance, but by absorbing and distributing shock, by being porous, by allowing its structure to dissipate energy. In our quest for peace, we often try to become impervious walls. Perhaps the path is to become more like Carbonado, polycrystalline. To allow our consciousness to be a community of experiences, thoughts, and sensations, bound together by the strong diamond-like bonds of our core being, yet porous enough to let the winds of change pass through without breaking us. Our rest can be an accretion of small moments of peace, sintered together into something unshakably solid. And its solitude, its beautiful cosmic solitude. It is not the loneliness of abandonment, but the solitude of unique origin. Each of us, too, carries a solitude, the unique, irreplicable perspective of our own consciousness, the specific history of our own stardust. Carbonado's story tells us that this solitude is not a barrier to connection. It is the very thing that makes our connection meaningful. We are singular points of the universe experiencing itself. In accepting our own solitary perspective, we join the community of all other singular perspectives. All the other bits of the universe looking back at itself, from rocks to stars to living beings. Now envision the stone back in the riverbed or resting in its museum case. Its work is done. It has delivered its message. It is at peace. It does not strive to be anything other than what it is. A piece of a star resting on a planet. There is a deep, final tranquility in this image. All struggle is over. All journeying is complete. It is home. This is the state we are moving toward, not the sleep of exhaustion, but the sleep of homecoming. The sleep where the boundary between self and universe softens. Where the carbon in your body remembers its kinship with the carbon in the stone, with the carbon in the distant nebula. Where the hydrogen in your water whispers the same secrets as the hydrogen trapped in Carbonado's pores for billions of years. It is a sleep of reunion. We have reached the end of our exploration, and the beginning of a deeper rest. The story of Carbonado, the black diamond, is complete. It is no longer a mystery to be solved, but a truth to be inhabited. A truth that says, you are not a stranger in a cold universe. You are the universe, temporarily arranged into a form that can wonder about itself. The stone is proof. As you settle into this final meditation, release the need to hold any more details. Let go of isotopic ratios, supernova mechanics, and polycrystalline structures. Let them all dissolve back into the wonder they compose. What remains is the feeling of a connection that transcends time and space, a quiet, majestic peace that comes from knowing you belong to something ancient and ongoing. Imagine your consciousness not as a separate entity, but as a localized gathering of stardust, just as Carbonado is. You are having an experience just as the stone is an experience of the universe. In this shared materiality, there is no other. The night sky is not above you, it is within you. The silence of the stone is your own silence, waiting beneath the noise of thought. This is the cosmic embrace. It is not an action performed by something external. It is the realization of a state that has always been true. You are already held by the fabric of space-time, composed of atoms born in stars, breathing the remains of ancient atmospheres, thinking with a brain built from elements delivered by asteroids. To feel alone is an illusion of perspective. Zoom out far enough, in space, in time, and understanding, and the boundaries blur. You are the universe resting, listening to its own story. So, as sleep draws near, let it be this kind of rest. The rest of the stone in the riverbed. The rest of the star's material after its long journey. The rest of a puzzle piece clicking into its place in a picture too large to see but deeply felt. You are returning not to nothingness but to your most fundamental state, a conscious part of the whole. Now let the soundscape complete its work. The luminous, flowing drone from the previous pause begins to slow. Its flow becomes a gentle, pulsing glow of sound, syncing with the rhythm of your own heartbeat, your own breath. The distinction between the sound out there and the rhythm in here melts away. They become one single, soothing, oscillating presence. This unified pulse gradually softens in volume, but not in presence. It becomes a feeling more than a sound, a gentle thrumming at the core of your awareness. It is the vibration of connection itself, the hum of shared existence. And then, with infinite gentleness, this feeling begins to diffuse. It expands, becoming fainter and wider, like a drop of ink in warm water, spreading until it is indistinguishable from the medium. It doesn't fade into silence, but into peace. A peace that is not the absence of sound, but the presence of wholeness. A peace as deep and dark and welcoming as the Carbonado itself, absorbing all fretfulness, all separation, leaving only the serene, knowing quiet of the cosmos at rest. You are home. The story is told. The journey is over. The universe is holding you because you are it. There is nothing more to do, nothing to solve, nowhere to go. Only to be, to rest, to sleep as stardust dreams. We've reached the end of our series. I'm grateful to you for treating me like part of your family and accompanying me, and I would be very happy if you supported me by subscribing to my channel so that I can continue sharing this information. Good night for now.